Okay, our last problem is use the figures to evaluate if f of x equals cosine of x. So first of all, our alpha and beta are given in these representations. Okay, first of all, let me come here and make a note that alpha right here, if I brought that down and made that into a triangle, what is the radius of this circle? Square root of 4, which is 2. Good. So that means this radius is 2. This is the x value. This is the y value. That means our y value is 1. How will we find our missing value here? Good. Pythagorean theorem. So I want you to pause it for a second and find the missing side. Okay, so b is going to be plus or minus the square root of 3, but since we're going to the left, we know we have that. Okay, now let's do the same thing for our beta so we can find some values that we need. This is going to be if I drew my triangle based off of this beta and made it to the x-axis, then this is a radius of 1. It's a unit circle, okay? Now, given this information, our x value is negative 1/3, so that means this would be negative 1/3. We're missing our y value, so do Pythagorean theorem, just like we did over here, and find your missing value. Okay, so our a is going to be plus or minus 2 square root of 2 over 3, and this value is going to be negative, so we want to plug that in, so we're going to use negative 2 square root of 2 over 3. Alright, so if we want to rewrite this as a function in terms of alpha minus a beta, okay, for example, so our function that was given is cosine alpha minus beta, so that it looks more familiar. We have our alpha minus beta. Okay, now we want to determine, we're going to pull our formula first of all, so let's do that. Okay, so using this information, all of this on this column is red, it's in relationship to alpha. So if I'm doing cosine of alpha, what would be the cosine of alpha over here? What's the cosine? X over your r, so that's going to be negative square root of 3 of 2. So let's write that down. So sine, let me come over here. So sine of alpha is your y over your r. So using this triangle, our y value over our r value is 1 over 2. So it's going to be 1 over 2. What about the cosine of alpha? It's your x over your r value, which this is our x and this is our r. So negative square root of 3 over 2. Alright, let's go ahead and do the same thing for beta, but let me do it in blue. Sine of beta is going to be negative square root of 2 over 2, 3. Right here, it's your y value over your r value, so it's just this over 1, which is just negative 2 square root of 2 over 3. And what about cosine of beta? Cosine is your x over your r, so that's going to be negative 1/3 over the r, which is a 1, so that's just going to be negative 1/3. So we want to use these values and plug it into this formula. So cosine of alpha is negative square root of 3 over 2. Cosine of beta, we come over here, is negative 1/3. Sine of alpha is 1/2. Sine of beta is this negative 2 square root of 2 over 3. Okay, now let's simplify that. That's going to give us a positive square root of 3 over 6 plus, actually, positive times a negative is a negative. Make that a little neater. Negative 2 square root of 2 over 6. Now we could factor out a 1/6 like we've been doing previously, and then that would just give us a square root of 3 minus 2 square root of 2. And that's going to be our answer. So this is a whole different presentation. Let me recap. First of all, they told us we're working with cosine, so that's how we knew we were going to have this. And they also gave us alpha and beta, but they gave us figures and equations. So we needed the radius to know that our radius is 2. This told us the location of our triangle, and we had to find the missing side. Then calculate sine and cosine using our definitions. Over here, we used our radius of 1, so we made our representative triangle according to our given figure. Found the missing side, calculated sine and cosine by definition. Then we pulled the formula for alpha minus beta right here, plugged in our values that we calculated here, and then algebraically simplified.